Hello, in this second video I'm going to be looking at life expectancy and why this is the most favoured way of measuring and comparing mortality. So very simply, what you're going to learn from this video is you're going to understand why life expectancy is one of the main measures used to compare populations, and I'm also going to be talking a little bit about trends in life expectancy over time and place. So mortality data is the basic data that's used to understand health inequality. If we want to understand the differential health outcomes between either different countries or between different subpopulations within a country, we tend to look at measures of death. And in all of the major health reports that you might have been reading as part of this module, from the Black Report to the Marmot Report, you will have encountered how these reports use core measures of mortality to assess inequalities in health. However, it is very easy to mislead with data on health and mortality, and you need to have a good understanding of how these mortality measures are calculated in order to be able to interpret them correctly. In particular, you need to understand that we cannot simply look at raw data. For example, it's inappropriate to compare the number of deaths either between a country or a region. Now, during COVID-19, many people became expert armchair epidemiologists and pored over the data that was released on a daily, weekly, monthly basis on how many deaths there were from COVID-19. But actually, a lot of this amateur examination was very inappropriate because raw counts of the number of deaths is never an appropriate way to really get a measure about how people's life chances vary over time and place. The main measure that we use to compare people's life chances is the measure of life expectancy. And if you read any of the reports on health inequalities, for example, if you read the Marmot Report, you will see that uses measures of life expectancy and also related measures of life expectancy to analyse health inequalities. So if you're going to have a handle in understanding the extent of health inequalities, you need to understand what life expectancy is and how it is computed. So to define life expectancy, it is the average age that an individual could expect to live if they experience the current age-specific mortality rate. It's important that you understand a couple of key things about life expectancy. It is a synthetic measure. By that means it is not a real measure of how old people are when they die. What it does is it summarises mortality across all age groups at one particular time. Another way of thinking about life expectancy is telling you that if a baby is born in one particular year and they experience the current age-specific death rates for the entirety of their life, this is the age that they would expect to live to. So it's important to remember that it's not the same as the average age of death, though often people assume that it is. So it's also very easy to misunderstand life expectancy and think that a life expectancy is giving the average age that people will die, but it's not. There's a subtle difference when we say that we're looking at the average age, the average number of years that a person could expect to live if they experienced the current age-specific death rates. And in particular, we find that in high mortality societies where infant mortality is very high, life expectancy can actually increase over time. So we can find that life expectancy can be quite low at birth, but after children have survived the first dangerous years of life, their life expectancy can actually increase. So life expectancy is computed from a life table, And I've done a separate video to show you how you compute a life expectancy from a life table. Now, we've calculated life expectancies of some form in England for a long time, and the first life tables were used to compute what were called the English bills of mortality in the latter part of the 17th century. And it was two members of the Royal Society, Edmund Halley, yes, the same Edmund Halley as of the comet fame, and also John Gaunt, who were first to calculate bills of mortality. But life expectancy and life tables really came into their own in the middle of the 19th century, where a statistician called William Farr pioneered the collection of official mortality analysis in England. And this was really pioneering work because William Farr's work was used to identify occupational mortality and the causes of infectious disease. It was important in Victorian society to understand the extent of inequalities and the impact that poverty was having on life outcomes in England, particularly in the major urban centres during the 19th century. So the calculation of life tables and life expectancy from life tables was really important in stimulating state intervention to improve public health, to improve life expectancy during the 19th century. And life expectancy at birth is the data point that's used to summarise a life table. And in fact, we can look at life expectancy at all ages. We don't just have to look at life expectancy at birth. But we're more used to thinking about life expectancy at birth, and that tends to be the summary measure that we use.
So just to give you a quick example of looking at different life expectancies at different ages, on this slide I'm showing you the life tables calculated for the Central African Republic for 2 years, 2019 and 2000. And in the first column we have the years. Now, this is an abridged life table. You can find out more about the difference between abridged and unabridged life tables in the video on calculating a life table, but it's basically giving you the life table for 5-year age groups. And then I have the different life expectancies at different ages for 2019 and 2000. So the very first row of data, which is for the age less than one year, that's the life expectancy at birth, and you can see how that has increased from 44.3 in 2000 to 53.1 in 2019. If you look at the second row of figures for the age groups 1 to 4 years, this is actually giving you the life expectancy at age 1, so it's the average number of years a child might expect to live from the age of 1, not from birth. You can see that something quite interesting has happened here, in that in both years, in both 2019 and 2000, life expectancy at age 1 is greater than life expectancy at birth. And this is simply because infant mortality is so high in the Central African Republic that the risks of dying during the first year have a big impact on the overall calculation of life expectancy. So once infants survive this first year, the overall life expectancy increases. And in this second table, I'm illustrating this important observation about life expectancy in high mortality societies, looking at the historical record. So this is the life table for women by age in England, 1845. So it's one of the life tables calculated by William Farr. The terminology is slightly different because it's an historical life table, but if you look in column B here, which is mean future lifetime of females of the age X, that's the same as what we call life expectancy. If you look at that column, you can see that life expectancy at birth, which is given in row 10 of this spreadsheet for the age 0, life expectancy at birth for women in 1845 was 42.16 years. And then you can see that life expectancy starts to increase. So by the time women have reached the age of 1, it's now 47.55 years, and by the time they reach the age of 2, it's 49.57, and by the time they reach the age of 3, it's 50.28. Again, life expectancy is starting to increase during these early years of life, because it wasn't just infant mortality that was very high in England in 1845, but so was childhood mortality. And you can see that it's not until the age of 20 that we actually get to similar life expectancies that women counted when they were born. And this is a really important thing to remember about high mortality societies. It's a very common mistake that people make, that they assume that because life expectancy in countries such as England in 1845 was so low, this meant that everyone died by the age of 40, and there were very few older people in the population. That's simply not the case. Many people did live to the ages of 60s, 70s and 80s. Life expectancy was so low because of the risks of dying in the first year of life, and also during childhood. And this is illustrated really well if you look at column E, which is the mean lifetime or the mean age at death of females actually living at each age. So that calculation at birth is the same as the life expectancy. So the mean age at death that women could expect at birth was the same as the life expectancy. But you can see that this mean age of death starts to increase. So by the time we get to the bottom of this table, for women who were 20 years, for women of age 20 in 1845, the mean age of death was 60. So we're obviously lower than life expectancy that we experience nowadays, but by looking at this chart, you can understand why, even with very high infant mortality and childhood mortality leading to low life expectancy, we could still have large numbers of people living into older ages.
But the good news is that when we start to look at life expectancies for the contemporary period, as long as we're not looking at high infant mortality societies in the global south, we do not find such a big impact of infant mortality, because infant mortality is very much lower than it was in previous times. So here we have life expectancy by age for women in the UK for 2018 and 2020, for the period 2018 to 2020. And these data are taken from the life tables that are produced annually by the Office for National Statistics. And ONS always computes the life tables for 3-year periods. So 2018 to 2020 is a summary of the mortality that was collected over those 3 years. And the next life expectancies will be calculated for the period 2019 to 2021. And here I've given life expectancy for the first 10 years of life. And as you can see, that women at birth could expect to live for 82.86 years if they experience the current age-specific death rates at that time. So a baby born in that period, 2018 to 2020, would expect to live until just under 83 years of age if they experienced the current age-specific death rates that were recorded over that 3-year period. If we go down to look at life expectancy at age 10, we can see that at age 10, women could expect to live an additional 73.21 years. We can see that actually that is slightly higher than the life expectancy at birth, because at age 10, if you're expecting to live another 73.21 years, that means in total you're going to be living 83.21 years. So there still is a slight impact of surviving the first year of life, but it's nothing like what we observed in the mid-19th century. But for this reason, because there is relatively little impact on life expectancy of surviving the first ages of life, we can use life expectancy at birth as a reliable measure for looking at, for comparing life chances over the entire life course.
So just to put those data from the United Kingdom into context, here you're looking at two charts that are looking at trends in life expectancy by place and time. So this is life expectancy for countries in the global north, and you have the data at two time periods, 2000, which is shown with the blue circles, and 2017, which is shown with the pink circles. So just to point out a couple of highlights from this graph. First of all, how poorly the United States is faring compared to other countries in the global north for both men and women, much lower life expectancy and a much smaller increase in life expectancy over this time period. You can see that all countries experience an improvement in life expectancy for both men and women during this 17-year period, but some countries have a much big improvement than others. So the countries that stand out as having big improvements include Ireland for both men and women, and Portugal for women, but also to a certain extent for men as well. The United Kingdom is about a third of the way up for male life expectancy, but towards the bottom for female life expectancy. And there has been some concern that in recent years, and this is pre-COVID, so we don't really want to look at the pandemic to be explaining this, there has been a stalling in female life expectancy in the UK. You can also see that women in Japan stand out as having the highest recorded life expectancy at this particular time. So life expectancy is just based on mortality statistics. But if you read current literature on health inequalities in the UK, you will come across another variation of life expectancy, which is called the healthy life expectancy. And this is an extrapolation of the principle of life expectancy to incorporate morbidity as well as mortality into our calculations. And it's argued by epidemiologists that it's more useful to look at healthy life expectancy, which is basically getting at the point at which one might expect to live to when you will either die or start to experience health that impacts on your daily life. So it uses data on mortality, but it also includes data on health, and it's a standard survey question that's used in many data that the Office for National Statistics collects on measures of good health. So it's getting at the age in which people might start to experience daily incapacitation in their everyday lives. And the importance about healthy life expectancy is that it reveals some very important differences throughout the UK. And here I just have some recent analysis from the Health Foundation, which is comparing healthy life expectancy for the local authorities with the best life chances, and those are the data in blue, with those local authorities with the worst life chances. And you can see that for both men and for women, there's a difference of around about 10 years between healthy life expectancy if you live in a healthy part of the country or if you live in a part of the country where health is not as good. So increasingly you will find this addition to calculating life expectancy is to include measures of mortality in the calculation. So that's a quick look at how life expectancy is used to compare life chances over time and place. I'm not going to be asking you to compute a life expectancy for this particular exercise because I don't really have time to teach all of the workings out. It would almost be in half a module in itself. But if you are interested in how you compute life expectancy, I've done a video on that which you can look at. And I would stress, if any of you are interested in a career in public health, and we have had people from our degree programme go into that line of work, then I would recommend that you do at least explore how you compute life expectancy, because it will be a really, really useful employability skill for you.